one goes. So this question was submitted by Even. Hopefully I said pronounced your name correctly. And he had a question that he sent over to me, and I wanted to just kind of spend a little time, kind of going a little bit more deeper dive of the explanation. Sometimes that I don't have the time in my open live Q&As to go ahead and do. This one was to factorize x squared minus 4. So let's go ahead and start with that. Again, remember factoring is we want to break up an expression to a polynomial, which is going to be a sum of monomials. We're going to want to rewrite it as a product of two monomials, or product of two binomials, but we want to just write it as a product, right? A multiplication problem. So right now we have x squared minus 4, and we want to be able to rewrite this as a product. Now, one thing I always tell my students is kind of like a trick. Whenever you see two terms, think difference of two squares or the sum and difference of two cubes. Typically, when we're trying to factor, those are going to be, besides factoring out the GCF, is going to be what you're going to be looking for. Now, in this case, since I only have one x term, I can't factor out any common terms, so I'm going to look at the difference of two squares. And that is exactly what we can do here. We have x squared minus 4. I recognize right now that x squared is a square number, and 4 is a square number, and it's obviously the difference. So if I wanted to factor x squared minus 4, I can just go and factor this using the difference of squares technique, which is a x minus 2 times a x minus 2. Okay, and I know that's going to work again because you can always check your work by using distributive property, right? Multiply the x times x. That's x minus 2 times x plus 2. The difference of two squares has the x minus 2 and x plus 2. So be careful with that. And you distribute here. And the reason why that plus or minus is so important is because what happens is it makes the middle term go to 0. And the reason why that happens here is x times x is an x squared, right? So negative 2 times x is a negative 2x. A negative x times 2 is going to be a positive 2x. And then we have negative 2 times positive 2, which is a negative 4. Well, you can see here that these go ahead and add to 0, which is just going to leave us with a x squared minus 4. All right? So the factored form here for the x squared minus 4 is going to be x minus 2 times x plus 2. So now let's go and move to the next question. So that was the factoring. We got that one done. And now the next one can sometimes be confusing here because we talked about the 3 consecutive integers. So let's not worry about the 3 consecutive integers right now. Let's just go and focus on what it says. It says show that x cubed minus x can be expressed as a product. All right, so again, if we're expressing something as a product, that is just a fancy way of saying let's factor this. So I have x cubed minus x. Now in this thing, I have two terms, right? But they all have an x, is actually factoring out the x. And I can actually factor out the greatest common factor here is an x. That's going to leave within x squared minus 1. All right. Then I notice, again, this x squared minus 1, that is, again, another difference of two squareds, right? X squared is a squared term, and 1 is a squared term. And again, we're subtracting the two terms. So I can factor this to x times x minus 1 times a x plus 1. Now, actually, that's the answer. That's actually done. You can see that we actually wrote this out as 3 consecutive terms. How are they written as 3 consecutive terms? And in this format, they're not. So what we need to do is rewrite them in consecutive. So let's pretend x is the number 5, all right? So if x was the number 5, if I take this middle term, 5 minus 1 would be 4. So this is going to be my first term. If I said x equals 5 here, then I'd have an x. And then the x plus 1, which would be, if we were using 5 as x, that'd be 5 plus 1. So that's going to be a 6. But if I just wanted to represent it as a product, any really, the first or the second would work, or any kind of combination that you have there. All right, so now let's go and take a look at the second, or the last example, the third example. So it says, hence show that n to the 5th minus 5n cubed plus 4n is a product of 5 consecutive integers. All right, so now we have a trinomial. And again, you can see that we have a n. So I'm going to factor out an n first of all. So I factor out an n, and we're leaving that. It's going to be an n to the 4th minus a, that's going to be a, so n to the 4th, a minus 5, let's see, that should be n squared, and that's going to be plus 4. And again, we're looking for a product. A trinomial can be factored into a product of two binomials. And again, we can use the same justification like we did for the difference of two squares to go ahead and factor this. So what I'm going to do is I'm going to rewrite this as n, and then I'm going to say, all right, I know that this can be rewritten as a product of two binomials. Now, the first two terms are going to multiply to give me n to the 4th, just like we had that x squared minus 4, if you remember from the first example. So what two terms would multiply to give me n to the 4th? Well, I could say n squared times n. Now it's where it gets a little tricky, because now our last two terms need to multiply to give me a positive 5, but when we combine those middle terms, it needs to give us a negative 5. So hopefully with a little practice, and this gets easier as the more practice you get, I recognize these two numbers to be -1 and -4. And again, you can just multiply this out if you have more time and you want to check my work. Now I recognize though that the n squared minus 1 is again a difference of two squares. So what we can do here is we have our n, then we have a n minus 1 times a n plus 1, and then we have an n minus 2 times an n plus 2. Now again, that is in the complete factored form, so we are good there if you just wanted to rewrite it as a product. Now if we wanted to rewrite it as a product in consecutive terms, well then again we're going to go from like the lowest number, right? Let's pretend again 5 is x, or n. So if 5 was n minus 1, which would be 4, then we'd have n, 5, n plus 1 would be 6, n plus 2 would be 7. So I would just rewrite this as a n minus 2 times an n minus 1 times an n. I'll just put parentheses around that. And then we have an n plus 1, and then we have an n plus 2. So there you go, ladies and gentlemen. That is how you would solve, or at least how I would solve a problem like that. Hopefully that was beneficial to you. And if you guys do have any questions, maybe I might make a video on it. Maybe I might answer it on my open live Q&A. I can't answer everything, but I love trying new techniques and seeing if they're helpful for you guys. So thanks again. Hopefully you enjoyed. Let me know if this was beneficial in the comments below. Cheers.